Welcome, my students and viewers. In previous two videos, I have done all the 4 tests, of course, in a very shorter way and in a very nutshell. I have explained them particularly applications of all the 4 tests. And all the applications were not explained in full detail because of the dearth of time, and your exam is very imminent and looming large. So that is why I just thought it proper to explain the applications of all the tests. So and just today's class, I am going to solve few MCQs related to those tests. And in just coming 1-2 videos, I shall be solving MCQs based on those tests. So let us start. First question is, we have to match list 1 and list 2. Here is population mean with known variance. I have explained there in the class that when the population mean with known variance, if the mean of population mean and variance both are known, then we use Z test. Second is this population mean with unknown variance. There too I had explained that when the population mean is unknown, we go for the unbiased estimate of the population variance, and there we use T test. Number 3, comparison of variance. This is ratio variance, and this is done by F test. And goodness of fit, a very famous test, that is chi-square test. So when goodness of fit, we have to conduct any test. In the context of goodness of fit, we use this chi-square and the S1 square by S2 square. The two variances of the two samples could be compared with the help of F statistic. And if the population mean is known but the population variance is unknown, then we use T test. And when the population mean with known variance is, then we use Z test, right? Number 2, the value of chi-square is 5 into 7. The value of chi-square in 5 into 7 contingency table. The value of chi-square in 5 into 7 contingency table is computed as 0.8. Now, the degrees of freedom would be, I had explained in the previous yesterday's class that if contingency table is of the order R into S, row into column, here 5 into 7, R and S, then here chi-square follows R minus 1 into S minus 1 degrees of freedom. So here is 5. So 5 minus 1 into 7 minus 1. So 6 into 4, and degrees of freedom would be 24. Whenever we conduct, and if, once again, if this contingency table is 2 into 2, R into S, then chi-square would follow 2 minus 1 into 2 minus 1, that is 1 into 1, that is 1 degrees of freedom. So if the contingency table is 2 into 2, then chi-square will follow 1 degree of freedom, and if it is of any other order, R into S, then chi-square will follow R minus 1 into S minus 1 degrees of freedom. This is what about the degrees of freedom. Number 3, a regression function with 4 independent variables has been found for 25 observations. What are the degrees of freedom for numerator and denominator in F test? In the denominator, degree is n minus k minus 1. Here is n is 25, k is the number of independent variables, and minus 1, so that is 20. And the degrees of freedom in the numerator, it happens to be k minus 1, that is 4 minus 1, that is 3. So that will be the answer. So these are the 2 guidelines, thumb rules for finding degrees of freedom in the case of this one. Number 4, sample size is 400, right? N is 400. And mean is 99. This mean is, the sample mean is 99. And the population mean is 100. And Z is 2.5. Find the value of population SD. Now here you must remember that when we conduct a Z test on single mean, then the statistic is Z equals x bar minus mu upon sigma divided by sigma upon root n. This sigma has to be found out and everything is given. The value of Z is given as 2.5. X bar is 99. Population mean is 100. Sigma is unknown and root 400 because n is 400. So this could be written as 2.5 equals, and one thing is to remember, while conducting any test, we take the absolute value of Z. Negative sign is outrightly rejected. So here 19 minus 100 would be taken as 1, and this root 400 goes in the numerator and it becomes 20 and divided by sigma. So now what appears? 2.5 equals 1 into 20 divided by sigma. So sigma is 20 by 2.5 and that is 8. So 8 would be answer. So this is how this statistic has to be kept in memory. This statistic, from this statistic you can just find out this thing. So this is what I am explaining. More questions. Question number 5. Question number 5 says that for any given data, mean is 180 and the very size of the sample is 100 and variance is 324, CV will be, if we remember the formula of CV is SD by mean into 100. Here mean is 180, it is 100, and SD, here variance is given. So variance is 324, hence SD is under root variance, that is under root 324, that is 18. So here it would come 18, 10 and 10. So the answer would be 10%. So 10% would be the answer. And if we don't consider the 100, then answer could be written as 0.1. That is 1 by 10. That will be the answer. So here it is given in the form of percentage. So it is 10%. Which statement is false? Out of given 4 statements, we have to identify the wrong statement. T distribution was given by Gossett. Absolutely correct. This is not wrong. Definitely T distribution was given by Gossett. Secondly, Tippett's table is used for random sampling. Definitely there is a Tippett table from where we just derive the numbers and we make the sample or any kind of simulations or anywhere and everywhere in statistics as well as in econometrics. This given Tippett table is used for finding or for getting or for obtaining random numbers, and from random numbers we go to make random sampling. So that is the correct answer. It is not false. Binomial distribution is symmetrical if P equals half, P equals Q, and that is half. For a binomial distribution, P plus Q must be 1. This distribution becomes symmetrical like normal distribution when P equals Q and both has its value as half. So half plus half becomes 1, and only in this case when P and Q both equals half, this binomial distribution becomes symmetrical. So that is also a correct answer. And number 4, this says that regression coefficient of y on x is equal to r. No. This is the wrong answer. This is wrong answer. So that will be the first answer here, correct one. The regression coefficient of y on x, byx, is r into sigma y by sigma x. That is the established formula for the regression coefficient of y on x. So byx, the regression coefficient of y on x is this r, correlation coefficient into standard deviation of y and whole divided by standard deviation of x. So this is, but here r, so this is the false one and that would be the correct answer. Number 7. For testing the association or independence, both are the two sides of the same coin. Just for testing the association or independence of attributes, in previous video I have explained it that particularly and specifically chi-square test is carried on when we have to test the association or independence of attributes. So here, and it was given by Carl Pearson, a very strong and powerful test. So this is chi-square. Analysis of variance known as ANOVA is carried out by using, when we have a multiple regression model and one dependent variable is being affected by various independent variables, then there we may be interested in knowing that out of the total variation of dependent variable, how much variation is being caused by what variables. So there we just rather filter or separate the various variances caused by the various independent variables, and when we make this table, it is make ANOVA table, it is an analysis of variance analysis, and in that there we use F test for testing the equality of more than two means. This is what is being done under F test in ANOVA analysis. So there we are using F test. So that would be the correct answer. Here says that for testing the significance of overall regression, the test to be used, t-test is used when one dependent variable is affected by several independent variables, and there we have to test the very independence or significance of overall regression, then t-test is used. So here answer would be the t-test. It is question number 10. We have to match the list. Z test, Z was given by Gauss. T distribution was given by Gosset. Chi-square was given by Carl Pearson, and F test was given by R.A. Fisher. So this is how the various names are associated with the various tests, and we should match like this. So these all questions I have solved into, and again, just coming few videos, I'll be solving important questions related to sampling and sampling distributions, and there I'll be solving few questions of probability too, because probability also is a very important chapter, though I have not covered probability in the usual class, but few important questions I'll be solving in those videos. So just in the coming videos I am coming with more questions and more MCQs related to these 4 tests and probabilities. So for today, and one thing to tell the students as well as the viewers, in these questions, if you have any problem, you please see my previous 2 videos. There I have explained all the 4 tests in full detail, their applications, their implications, their uses, their significance, and all the important informations I have put there. So all the students must see the 2 previous videos which have explained the significance of all the tests, and then they should come over here, this MCQs. It will be a little bit comfortable one, and in the coming videos too, I am just going to solve few more questions on related to these tests. और प्रयास है कि जितना हम काम इसमें कर सकें, बच्चों के लिए जितना हमसे हो सके बन पड़े, तो देख रहे हैं आने वाले वीडियोस में हम कुछ और क्वेश्चंस इसी के सॉल्व करेंगे। और नेट वाली एग्ज़ाम जो शेड्यूल्ड है, अगर हो जाती है तो उसके बाद फिर फुल डिटेल में हम सारे डिस्ट्रीब्यूशंस को हम एक्सप्लेन करेंगे। इफ ऑल द फोर टेस्ट्स, I will start from the probability. I will explain the probability in full detail, and thereafter I'll be shifting to this sampling. So this will be done in the let this exam be finished on 2nd May, whatever it is scheduled. Thereafter I'll be again coming on here the YouTube, and I'll be explaining all the tests in full detail, quite detailed. So this is all. Best of luck, my students. Thanks.